right, so I'm just going to run through, this is the quiz for Year 10 from Week 6. Just running through the questions, making sure we're all okay with everything. Hopefully you know your own name and who your teacher is. All right, let's have a look. What is the size of the angle marked in P? Now, a couple of these I've already done, but let's just talk through. I want to find angle P there. How did I go about this? Well, I notice I've got two sets of isosceles triangles. This is also a P. That may or may not be useful, but what else have I got? I've got 50 degrees here, so I'm going to call these angles alpha and alpha. 50 plus alpha make a nice triangle. So angles in a triangle add up to 180 degrees. I've got an equation written for that over on the right hand side here. 2 alpha subtracting 50 from each side, I've got 130 degrees equals 2 alpha. Alpha equals 65 degrees. So then I said I could probably find angle theta. How am I going to find theta? Well, I'm going to go 180 minus 65. 180 minus 65, 115 degrees. Then I've got theta plus 2p equals 180. And we go ahead and we solve that equation, and we get p equals 32.5. Another way you could have done it, once you got alpha equals 65, we could have gone straight to alpha equals 2p. Why is that? Because the exterior angle of a triangle is equal to the sum of the opposite interior angles, P and P. So that angle alpha would equal P plus P, and I could do it that way. 65 equals 2P. 32.5 equals P. And you're good to go. All right, what about the next question? Exterior angle, we just talked about that. The exterior angle for any polygon, just take any side and extend it. The exterior angle is that angle that's formed there. Doesn't matter if I took the top side and extended it in the other direction. That angle there is the exterior angle. Whichever way you look at it, it's always the same. There's a nice, easy rule for the exterior angle of a regular polygon. And that is you take 360 degrees and divide it by the number of sides. Because if you think about it, if I was starting facing in this direction and I wanted to walk around my octagon in this case, I would have to make a turn, walk the length of the side, make another turn of the same angle, walk the length of the side, make another turn of the same angle, walk the length of the side, and so on. If I did that around the octagon, well, I'd have made 8 turns by the way I was coming around and facing back to where I started. If I've turned around a full revolution, I've turned 360 degrees, 360 divided by 8, 45. That's your answer you're looking for. The shape above is a kite. What is the size of the angle marked at T? Well, I've got 110 and 110. T is this angle over here. Do I have enough information? The only information I know about kites is that it has one pair of opposite angles that are equal. If they hadn't told me anything about these other angles at the end, at this point I do not have enough information to come up with an answer. So that's it. Can't do anything else. This one here. What is the size of the angle marked A? A and 105 are co-interior. It says it's a parallelogram, so I'm allowed to think of those sides as being parallel, or these ones. But those two being parallel, the top and bottom, co-interior angles are supplementary. Add up to 180. Do the maths. B must be my answer there. Factorise x squared minus 9x. It's amazing how often people forget the easy factorising step of just taking out a common factor. You could, of course, expand these to check, but it's faster just to get it correct. Take out the common factor, x. X outside of x minus 9. That's the answer I'm looking for, A. Moving on. What is the value of 3/7 plus 5/9? We've been doing this for a long time now. Fractions to add or subtract, you've got to have a common denominator. 7 and 9 both go into 63. So I'm going to multiply the first fraction by 9 over 9. And the second fraction by 7 over 7. Remember, multiplying by 1 doesn't change what it's worth. It's just a bit of panel beating. Make it look the way we want it to look. 3 9s are 27. 5 7s are 35. The denominator, 9 7s were 63, weren't they? 30, 40, 50, 62 over 63. Answer A. Moving on. Look, we're racing through these questions. It doesn't take very long. What are the values of x and y? X is this distance here. The other distance that makes up that total horizontal change is x plus 8, because I've got the 8 centimetres from this distance here. So x plus 8 equals 19. So I'm looking for x equals 11. And I'm doing the same thing vertically. This y is made up of 6 plus 10, y equals 16. Do I have x equals 11 and y equals 16? Yes, I do. Right as rain, we can move on to the next question. Sorry, my computer just not wanting to move on there. What is the area of this sector to one decimal place? So the area of a sector, it's a fraction of a circle. So it's whatever angle is out of 360. That's how I measure the fraction. Area of a circle is pi r squared. So that's my rule for the area of a sector. In this case, I've got 150 over 360 pi, and the radius is 12 squared. Okay. Ooh. 15 over 36. You could use your calculator at this stage because it says one decimal place. I don't have one with me, so I'm going to do it without the calculator first just to check what we would have got. 15 over 36, 3 goes in each of those. So that's a 5 over 12. Oh, one of those 12s can cancel with that. Oh, I've got 60 pi. 5 times 12 is 60, so the area is going to be 60 pi square centimetres. Well, pi is about 3.14, so 3 times that's 180, a bit more than 180. We can see our answer there. Who needed a calculator anyway? Moving on, question 10. Excuse me. What is the volume of this triangular prism? Volume of a prism equals the area of the base, or the cross-sectional area, multiplied by the height of the prism, or the length of the prism if it's lying down like this one. Number of different ways you can do it. What's the area of this triangular base? It's a half of the base times the height, so it's volume is going to be a half, the base is 10, the height is 4, because obviously it's half of that. The triangle is half of the rectangle, yep, and then we're going to multiply it by 20. Volume is equal to 20 times 20, 400 cubic centimetres, because it's a volume. And we're done. Moving on. Which of the following calculations will give the surface area? So what's my rule for surface area for all prisms and cylinders? 2 times the area of the base. 1 for the top, 1 for the bottom. Plus the perimeter of the base multiplied by the height or the length if it's lying down. But we get the idea. So the area of a base, well, that's 2 pi r squared, isn't it? We know that a circle is pi r squared. The perimeter of the base, it's a circle, so it's 2 pi r multiplied by the height. Well, which of the rules is going to involve those things? R is going to be 6, so I'm going to have 2 times pi times 6 squared is 36, plus 2 times pi times 6, and the height was 10. Now you can see they've partially simplified some of these just to be difficult. The 2 pi by 36 or 2 pi 6 squared, we definitely want one of those two. And then we're supposed to have 2 times pi times 6, or 12 pi multiplied by 10. That's the other one with the 12 pi multiplied by 10. I think C is our correct answer for that one. And we're going to move on to the next one. Formula for the surface area of a sphere, 4 pi r squared. I won't tell you that in the exam. I expect you to know it. You know it now already. You just heard it. What is the surface area of a hemisphere? Hemisphere is a sphere that's been cut in half. Now you've got to be careful there because we've created a new side. That bottom has an area of pi r squared. The curved top has an area of 2 pi r squared because it's half of the sphere. So the surface area of the hemisphere is actually going to be 3 pi r squared, where the radius is 8. 8 eighths is 64, by 3 is 192 pi square centimetres. 192 by 3, around at 200. It's going to be close to 600, isn't it? Well, there's only one that's really viable there. 603.2 square centimetres. And we've got our answer. Question 13. 1 over 8 to the power of negative 2/3. Just take it slowly with these. Keep your head and your wits about you and you'll be fine. Negative indices are the worst. What do? They move things from the bottom to the top or the top to the bottom. So what I can do is actually rewrite this, write the reciprocal of that fraction, 8 over 1, which of course I'm just going to write as 8. And now I've just got to the power of 2/3. It's made my life a little bit easier. When I'm dealing with fractional indices, remember a to the power of m over n is the nth root of a to the power of m. That's my rule. Often I'll find it easier to do the root first. So what I would do in this case, a to the 1/3 all to the power of 2. That's using my a to the power of m to the power of n equals the product of those two powers. Using that in reverse, I've got 2 times 1/3. That's how I got my 2/3. I'm going to put the 1/3 inside the bracket, the cube root inside the bracket, because the cube root of 8, I know, is 2. So now I've just got 2 squared, 4. There's my answer. Question 14. Which of the following lines is not parallel to that line? Well, we just want to rearrange all of them to have y equals mx plus c. This line has a gradient of -2. So I'll just check the gradient of all the others. This one here is 3y. To get it to be y equals, I need to divide by 3. 6 divided by 3 will be 2. 8 over 3 is 8/3, but it's the -2 I'm interested in. That's the same. So it is parallel. Let's have a look at B. Expanding my bracket, -8. Negative by negative is plus 2x. That has a gradient equal +2. +2 and -2 are not the same. I think this is my answer. Let's just double check. This one's already in the right form. They've just written them in the wrong order, but that one definitely has a gradient of -2. Why didn't I write that up there? And this one here, when I expand it, 2 take 2x also has a gradient of -2. So now I'm very confident B is the one that does not have the same gradient. A repeat question. This is the third appearance of this question. Which of these equations has the biggest solution? Stop trying to do it in your head. Do the working. Too many people are saying, 3 equals 21x, x equals 7. Well, last I checked, 7 times 21 is 147. How do I get x on its own? Divide by 21. Divide by 21. 1/7 equals x. This one here, subtract 4 from each side. X equals 5. This one here, add 3 to each side. X equals 22 divided by 4. What's that going to be? It's going to be 5.5. If you wanted to, but you should be able to see that it's definitely more than 5. And finally, -x equals, I subtract 9 from each side, I've got 6. Well, quite clearly, C is going to be the correct answer here. Don't try and do them in your head. Do a little bit of working. Save yourself time in the long run. Line parallel to 4x take 1 passes through the point 3, 2. What is its equation? Parallel line, so it has the same gradient. M is equal to 4. So now I can write y equals 4x plus c, and I substitute in the point I know, which is the point 3, 2, to solve for c. So y is 2, so I've got 2 equals 4 times 3 plus c, 2 equals 12 plus c, -10 equals c. So I've got a gradient of 4, a y-intercept of -10, y equals 4x take 10. Answer D. X over 4 divided by x over 6, all to the power of a half. Two ways you can do it. You could simplify inside the brackets first. X to the power of 4 divided by x to the power of 6. I do subtraction. I've got x to the power of -2, all to the power of a half. Then I multiply the powers, don't I? -2 by a half is -1. So if x to the -1 equals, well, I can start with x to the n on this side. X to the n equals x to the -1, n must equal -1. What's the other way you could have done it? You could have just expanded the bracket to begin with. So I could have gone, power raised to a power. I could have had x squared over 6 times a half is 3, x cubed. 2 divided x squared divided by x cubed, so I go 2 minus 3. That's x to the -1, and you can see again, n would equal -1. Lots of ways of getting to the answer. What is the perimeter of the trapezium? 0.9 centimeters, 10 millimeters, 15 millimeters. This one's obviously 10 millimeters. What do we have to do? Make sure our units are the same. 0.9 of a centimeter is 9 millimeters. 10, 20, 35, and 9 makes 44 millimeters. Done. Isaac is trying to solve the equation on the right. Here are his steps. Which steps, if any, are correct? Well, I would be subtracting y from each side to get my y's together. That would give me 5y minus y is 4y equals 1. Looks like the first step's correct. What do I do next to get y on its own? What's the opposite of multiplying by 4? Dividing by 4, dividing by 4. I'm expecting to have y equals 1/4. Looks like step 2 is incorrect. Which steps are correct? Only step 1. Question 25 to the negative 2. What do we do with the negative index? You write the reciprocal of it, don't you? 1 over a to the power of m. So 5 to the negative 2 equals 1 over 5 squared. 5 squared is 25, so I'm sure we have that answer there, B. What is the exterior angle E in this pentagon? We've already done this one, haven't we? 360 divided by the number of sides. 360 divided by 5, 72 degrees. Which number represents 2x take 2 is greater than negative 4 and less than or equal to 4? Well, I really want to know about x, not about 2x minus 2. We can solve these the same way we solve equations. I'm going to add 2 to everything. Negative 4 plus 2, negative 2 is less than 2x, which is less than or equal to 6. To get x on its own, what do I have to do? Divide by 2. Negative 1 is less than x, which is less than or equal to 3. Less than, it's going to be an open circle, less than or equal to a closed-in circle. This circle's at negative 1, the closed-in circle's at 3. You've all seen it sitting there already, haven't you? Ideally what they would do, and what you will do in your exam, they're talking about solutions for x, put an x on your little number line there. Show that it's the range of x values. Which of the following is the correct solution for the inequality? Squared ones are tricky. Do not get fooled. When I try to square root, x squared is less than 4, a lot of us are just going to say x is less than 2. Would that necessarily work? What about if x equaled negative 5? Negative 5 squared equals 25. Is 25 less than 2? It's not. And we've got to be careful when we're dealing with squares. X squared is less than 4. What I'm really saying here, where x is less than 2, I could also have negative x, x has to be greater than negative 2. If you think back to your parabolas, this is equivalent to saying x squared minus 4 is less than 0. X squared minus 4 looks like this, doesn't it? It's just a parabola that's been shifted down 4 units. It's got intercepts at negative 2 and 2. You can see here that it's less than 0 between negative 2 and 2, or when it's greater than negative 2 and less than 2. Greater than negative 2, less than 2. That's the answer I'm looking for there, D. Question 24. Which letter describes a region where x plus y is greater than 2? So when I add the coordinates together, the answer is greater than 2. And this one, where x is less than or equal to 1. Well, here's my equation, x equals 1. And where are the x values less than or equal to that? Of course, they're in that direction. So I'm either interested in B or A at this point, because that one's definitely the easiest one to see whether it's been satisfied. Here's my equation, the red equation. X plus y is greater than or equal to 2. Well, let's just check. If I use the coordinates of A here, negative 1 and 1, if I add them together, I get 0. Is 0 greater than or equal to 2? No, it isn't. What about the coordinates of B? Well, looks like it's about maybe a half or a third plus 2 and a bit. Are those two numbers together going to be greater than 2? Yes, they are. So which letter describes the region? The region we can see highlighted between the two lines there, or region B. Doing crazy things and moving around on me. We're doing well. I'm just going to pause and have a drink before I start coughing again, and then we'll keep going with the rest of the question. Excellent. Pushing ahead. What inequality is represented on the number line? Well, it's values less than, not including 1, less than negative 1. They haven't told us it's an x1. Let's put the x on there for them. X is less than negative 1. Answer A. We are up to question 26. Flying through these. Which of the following lines is perpendicular? Perpendicular gradient. The second gradient, if it's perpendicular to the first one, is the negative reciprocal of the first gradient. Or the product of the two gradients equals negative 1 for perpendicular lines. If this one is 3, I'm looking for a gradient, the negative reciprocal of 3, negative 1 over 3. Which one of these has a gradient of negative 1/3? A. Question 27. Which of the following lines is not parallel? That has a gradient of 3. This one, if I expand the bracket, 3 times x is going to have a gradient of 3. Next one here, 2y equals 6x. If I divide everything by 2, y equals 3x. I don't need to finish it off. That has a gradient of 3. Y equals 2 minus 3x. This one has a gradient of negative 3. That's going to be the one that's not parallel. Last one you can see is definitely parallel as well with a gradient of 3, so we know we got it right. What is the area of this circle in terms of pi? Pi r squared. R equals 6. So it's going to be 6 squared. 36 pi square centimetres. Area, two-dimensional, should have square centimetres. 36 pi square centimetres. Answer C. Circle has a circumference of 30 pi. What is its radius? So the circumference we know is 2 pi times the radius. So 30 pi equals 2 pi r. I'm going to divide by 2 pi to get the radius on its own. 30 divided by 2 is 15. 15 is the radius, and it was in centimetres. Well, they didn't give us units, but they're giving us centimetres this time. That must be the one they mean. This one's a repeat question as well. People continue to get this wrong. How do I rearrange this to make B the subject? That means get it so that it's B equals. Well, I'm going to get rid of this dividing by 2 first. I'm going to multiply by 2 because that's the opposite of dividing by 2. So I end up with 2a equals b times h. To get b on its own, well, I've got to divide by h, don't I? That's the opposite of multiplying by h. So the base is 2a divided by the height. Answer C. We should be comfortable with that. If you're not comfortable with that, we have to practice for 10 advanced maths. Order of operations is important here. 5 minus 3 times 2 all squared. That should be 5 minus 3 times 2 is 6 all squared. 5 minus 6 is negative 1. When I square negative 1, D is equal to 1. The sum of the interior angles in an octagon. So you can learn the sum of the angles. Sum of angles in a polygon. Is always the number of sides minus 2 multiplied by 180. You could use that rule and work it out. What else do we know? Well, we know the exterior angle (360) divided by the number of sides. So in this case, 360 divided by 8 would give us 45. We did that question earlier. That'd make each interior angle 135, and you can go 8 times 135. But by far the easiest way to do these questions that I found, pick any point. From that point, draw a line to every other vertex. You can see I don't need to draw a line along 2 of the sides because it's adjacent to it. That's why it's the number of sides minus 2 up here. How many triangles have I got? 6 triangles. 6 times 180, 1080. Calculate the volume of a rectangular prism. Volume of area of the base times the height. 3 by 4 is 12 multiplied by 6. Volume is 72 meters cubed. A volume has cubic units, 3 dimensions. Don't fall for the trap where they've only given us meters squared. Cafe offers 3 starters, 4 mains and 2 puddings. How many different choices could be made? This is a great chance for your tree diagram. How many choices have I got here? 3. For each of those choices, regardless of which choice they make, they could choose any of the main courses. So for each of those 3, I then have 4 choices. And after each of those choices, each of those 4, it doesn't matter which dessert I choose, which main or which entree I've chosen. I've still got 2 desserts to choose. So I've got 3 starters, 4 mains, 2 puddings. Multiply those numbers together. 3 multiplied by 4 multiplied by 2. 24 different meals. Diagram shows a scale drawing of the plan of a rectangular football pitch. Find the exact length of the diagonal. This is a Pythagoras' theorem question. The length of the diagonal squared is going to be 3 squared plus 5 squared. 9 plus 25, d squared equals 34. D equals root 34 centimetres. Read that? Rectangular football pitch, centimetres. That is a very tiny football pitch. Which of the following is true? X minus 3 multiplied by x plus 2 is less than 0. Oh, we've got to try and figure this out. Here's a hot tip. How do I have things being less than 0? I have a positive multiplied by a negative, or I could have a negative multiplied by a positive. It's the only way I could have a negative solution when I'm multiplying two numbers. What is going to make this bracket positive? Well, it's going to be equal 0 when x is 3. If x is bigger than 3, x minus 3 will be positive. So this one, I need x to be greater than 3. For this one to be negative, I'd need x to be less than negative 2. Can I find an x value that's going to be both greater than 3 and less than negative 2? Not at the same time, I can't. So that one's not what we're looking for. Let's have a look again. If I need this bracket to be negative, I need x to be less than 3. Then I'll have a negative value. For the other bracket to be positive, I need x to be greater than negative 2. So I need x to be less than 3 and greater than negative 2. How do I write that? X is greater than, because it's at the big end, greater than negative 2, but still less than 3. That's what I'm looking for. Answer B is what I'm after. Daniel and Tom share some money in the ratio 5:9. Tom received £24 more than Daniel. How much money was shared between them at the start? Well, £24 must represent the number of, you can see there's a difference there of 4. £24 must represent 4 parts of my ratio. If I divide by 4, I'm going to get £6 equals 1 part. How much money was shared between them at the start? Well, that's the total number of parts. 9 and 5 make 14. 14 by 6 is going to give me £84. Check it, make sure you got it right. 5 parts of that is going to be £30. 9 parts of that, 9 sixes are 54. If I want to reduce that to a ratio, am I indeed going to get 9:5? Yep, 6 goes into both of them, and I get 5:9. Happy as Larry. What is the ratio of x to y? Similar figures, so the sides are in the same ratio. So this slant side divided by the base, x over 5, is going to be the same as x plus y over 15 over the long base. That's the trick there. You've got to remember this for the larger triangle, the entire length is x plus y, not just y. So what can I do to try and make these equal? I'm going to get rid of my denominators by multiplying by 15. That's always nice. So we end up with 3x equals x plus y. Subtract x from each side. 2 lots of x equals y. So we want to have the ratio of x to y. Well, if x equals 1, what's y going to equal? You can see from the equation y is going to equal 2. So it must be 1:2. All right, moving on to our next question. These two shapes are similar. Calculate the volume of liquid that the smaller cylinder can hold. First thing we want to do is find our scale factor to go from the smallest to the larger one. So I can do my scale factor equals the image or the enlarged one. In this case, 15 divided by the smaller one. 6, 15 over 6. You're either going to get 2.5 or 5 over 2. I don't really mind which way you want to think of it. Actually, I do mind. I prefer fractions, but it's okay. What's the important thing with this question? To go the other way, we need to multiply to increase something. We're going to need to divide by that scale factor to reduce it. But a volume, the important thing to remember here is it's three-dimensional. So the volume of the small one is going to be the volume of the large cylinder, 1800 millilitres. And I'm going to divide by that 5 over 2, or 2.5, 3 times. Excuse me. Once for each dimension. So I go 1,800 divided by 5 over 2 cubed. You can push buttons on your calculator for that one. I'll allow you to do that. 115.2 millilitres. Ooh, we've jumped around here. Come on, respond for me. My little OneNote has stopped responding for a second. Magic way to solve that. Shrink it down, make it bigger again. Oh, it's taken us back in time. But there we are, we're ready to continue. So 115.2, yes, that was answer B. I don't think I remember to circle that, or indicate it anyway. These two shapes are similar. Calculate the length of the missing side of shape A. Here, I've got a ratio of the areas. So my area scale factor is a squared factor. The scale factor squared is going to be the big area divided by little area. Why is it squared? Because areas are two-dimensional. So my squared scale factor, 80 divided by 40 is 2. So my linear scale factor, what's the square root of 2? Root 2, correct. So the small side, to get to there, to go back to the smaller one, I need to divide by root 2. So my question mark is going to be 8 divided by root 2. Of course, you're not going to be rude enough to not rationalise your denominator. 8 root 2 over 2, or 4 root 2 centimetres. Answer C. Continuing on, 41, we're getting closer. Which rule would you use to prove the following triangles? They're matching sides. That's a matching angle. This is a matching side. Side angle side. Answer A. Write the following number in standard form. We place the decimal after the first non-zero digit. So place it after the 4. How far did it move? 3 places, so it's multiplied by a power of 10. It was a number that was less than 1 to begin with. So it must have been being divided. Or you can think about it as 4 tenths, hundredths, thousandths. Oh, so it's divided by 1,000 or multiplied by 10 to the negative 3. 4.03 by 10 to the negative 3. There's our answer right there. Downhill run. What is the gradient of the following straight line graph? Rearrange it to get y equals mx plus c. Alright, added x to each side to get that expression. Now I'm going to divide by 2. Don't mind whether you write it like that or if you write it as, or even all of those show me the same thing. The gradient of x is 1 over 2. The coefficient of x is 1 over 2. That's the gradient of the line. This is a graph of 5 minus 3x. What are the coordinates of P? P is an x-intercept. If I have an x-intercept, I know that y equals 0. So I solve 0 equals 5, take 3x. That's the same as 3x equals 5. Divide by 3, x equals 5 thirds. So x coordinates come first. So it's going to be 5 over 3, comma, 0. Which of the following points does not lie on the line? Well, here it's just a matter of substituting in. If x equals negative 1, 3 by negative 1 is negative 3. Take away another 6 would be negative 9. That one is on the line. 3 times 1 is 3, minus 6. 3 minus 6 is negative 3. B is on the line, 0 and negative 6. If I put 0 in for x, I get 0 minus 6, negative 6, negative 4, negative 6. If I put in negative 4, I get 3 times negative 4 is negative 12, minus 6 is negative 18. That is not negative 18. That is the one that does not lie on the line. Answer D. What is the equation of this line? It's a vertical line, so all the x-coordinates are the same, so the equation looks like x equals a number. What do I notice about the x-coordinates anywhere along there? Correct. They all have the same x-coordinate of 2. X equals 2 is the equation of the line. If you were to write this equation in the form y equals mx plus c, what is the value of m? M is my gradient. Find 2 points that are on lattice points. Points that go through exact coordinates makes it easier. How do I get from one point to the other? I rise by 2, and I move to the right by 1. So my gradient is 2 over 1, rise over run, which is of course just 2. Answer B. On to question 48. Writing the equation of this line in the form y equals mx plus c. What is the value of c? C is my y-intercept. My y-intercept is negative 2. Notice if they ask for the value, you can just write -2. A little earlier they asked for the coordinates. We had to give coordinates. Read the questions carefully. Line has a gradient of 4 and passes through the point. What is its equation? If it's got a gradient of 4, it's y equals 4x plus c. Now I can sub in the point 1, 6 to solve for c. 6 equals 4 times 1 plus c. Well, that's just 4. Take away 4 from each side. I've got c equals 2. I've got the gradient of 4x, so it should be 4x plus 2. Answer A. Which of these calculations would give you the gradient passing through the points? Take your time to label it. x1, y1. x2, y2. Gradient change in y divided by change in x, or y2 take y1 over x2 take x1. So in this case, that would be 5 minus -2 divided by 4 minus 6. Do I have one of those written anywhere? Well, 5 minus -2, I guess that's a 5 plus 2. Taking away a negative, positive, you can see there we've got answer C. What is the value of S if the following substitutions are made? Well, let's just make them and find out. Use brackets when you're substituting in. Make sure you don't make any mistakes. 5 and t is 4 squared. S is going to equal 3 4s are 12. I'm just going to leave my half there for the moment. 4 squared is 16, 5 16s are 80. Half of 8 is going to be 40 plus 12, 52. Done. Didn't want to write that last little line. When expanding, before simplifying, there are 4 terms. Which option below contains 2 of these terms? Well, let's expand them and see the 4 terms. 3 by 2 is 6. 3 by 2 root 5 is 6 root 5. -5 by 2, -2 root 5. -5 by 2 root 5. Positive times a negative is a negative. Root 5 by root 5 is 5. 2 times 5 is 10. They're the 4 terms. Which one contains these 2? Well, that one's not in there, so that's no good. B, -root 10. I don't see a root 10. That's no good. 6 is there. 2 root 5. Well, it's a -2 root 5. -2 root 5, -10. That's the one we want. Rationalize the denominator. Multiply by the conjugate. Use your favourite rule in maths, the difference of 2 squares. Why is it your favourite rule? Because it's going to make your life easier, so we use it. My numerator is going to be 5 take root 3. On the bottom I'm going to have 5 squared minus root 3 squared. I know I'm working across the page for obvious reasons here. You would work down the page when you're given room to do it in an exam. 5 squared, 25. Root 3 squared is 3. 25 minus 3, 22. 5 take root 3 over 22. Answer A. Question 54. What is the value of the unknown length x to 3 significant figures? Well, your guess is going to be as good as mine here. What do? I'm going to have to use Pythagoras' theorem. 13.2 squared equals 6.5 squared plus x squared. X squared is going to be 13.2 squared minus 6.5 squared. X is going to be the square root of 13.2 squared minus 6.5 squared. Well, I can already rule out it's not going to be longer than the longest side, so B is no good. D is no good. I've got 2 to choose from. To 3 significant figures, wow, I didn't even need to do any calculations. This may have been the correct answer. I'm assuming if you do it on your calculator, you're getting something that looks like that. 3 significant figures, start counting at the first non-zero digit. 1, 1, 5. That one's to 3 significant figures. That's going to be my answer right there. Answer C. Find the value of the trig function indicated. Cotangent. SOHCAHTOA. Cotangent is the reciprocal of sine. If I know that tan theta is opposite over adjacent, cotangent of theta, adjacent divided by opposite. Opposite. Adjacent. Hypotenuse. Adjacent divided by opposite. 6 over 4 or 3 over 2. Really close now. Find the value of the trig function indicated. Tan theta. Label my triangle. Opposite. Adjacent. Tan theta equals the opposite divided by the adjacent. So I have 8 root 2 divided by 14. Common factor there of 2. 4 root 2 over 7. Answer B. Find the value of the trig function indicated. Secant of theta. That's the reciprocal of cosine. I can see the third letter. That's my little clue. I know that cosine theta is adjacent over hypotenuse. So secant theta equals the hypotenuse divided by the adjacent. Label our triangle. We'll label our hypotenuse and our opposite. That must be the adjacent. And after hypotenuse divided by adjacent, 17 over 15. Secant again. Oh, okay. Hypotenuse, opposite, adjacent. Secant theta, we just had a look at it, was hypotenuse divided by the adjacent. 15 over 12, that's going to simplify down to 5 over 4. Find the measure of the angle indicated. Round your answer to the nearest tenth. We're going to do the same thing we always do. We label our sides. Adjacent, hypotenuse, and opposite. And we can see from this, adjacent and hypotenuse, we need cosine. So I've got cosine of theta equals the adjacent side 5 divided by the hypotenuse 9.5. To get theta, I've got to do the inverse cosine operation, which is, of course, arc cos. Try and remember to use that notation and terminology rather than cosine of the negative one, because that's ambiguous. Theta equals arc cos of 5 over 9.5. Guess what? I don't have the arc cos of every number memorized, but over here you would have noticed I paused just before. I've gone into Desmos. Make sure you tell Desmos you're working in degrees. Little spanner there gets you into that. Arc cos, look, it recognises it. It understands maths very well. 58.243 lots degrees. Let's go for 58.2 to the nearest tenth. One more of these. Opposite. Touching it, but not the hypotenuse, is the adjacent. This is the hypotenuse. So I've got an opposite side and an adjacent side. I need tan. Tan of theta equals 14 over 12. Inverse tan function is called arctan. You could simplify that or not, because your calculator is going to give you the same answer either way. Arctan of 7 over 6. Let's see if we can get that happening over here. Didn't want to behave for me, but we got there in the end. 49.39 degrees, which will be 49.4 to the nearest tenth. Answer D. Complete this statement. 600 square centimetres equals how many square metres? To go from centimetres to metres, remember, let's just do our little diagram. Millimetres, centimetres, metres, kilometres. We know we usually multiply by 10 or divide by 10. I was going the wrong way for a second there, wasn't I? When you're going to smaller units, you'll have more of them. When you're going to larger units, you'll have fewer of them. In this case, 600 square centimetres, I want to go to square metres. What's the difference that I make to these, whether they're squared or cubed? I just, for squared, square each of these conversion factors. If it was cubed, I'd cube each of the conversion factors. So to go from centimetres, square centimetres to square metres, I've got to divide by 100 squared. I was working in black, not in blue. Chose the wrong colour there. So 600 divided by 100 squared, divided by 100, divided by 100 more, 0.06 square metres. A piece of rock has a volume of 20 cubic centimetres and a density of 500 grams per cubic centimetre. Which of the following calculates its mass? Well, this is its volume, and then the density, it's 500 grams for each cubic centimetre. I want to end up in kilograms. Well, let's have a look. I can get my density, or my mass. You can see from the units, it's going to be the density multiplied by the volume. So in this case, 500 grams per centimetre cubed, and I'm multiplying it by 20 cubic centimetres, I can calculate my mass nice and easily. My cubic centimetres are going to cancel. 500 by 20, 5,000, 10,000 grams. But what do I have to do to change grams to kilograms? Divide by 1,000, isn't it? So I need to have 500 being multiplied by 20 and then dividing by 1,000. 500 multiplying by 20, dividing by 1,000. C is the answer that I want there. One to go, maybe? Oh, I think that's it. Lucky last. 1.3 hours to minutes. For some reason, people get these things confused. How many, to go from hours to minutes, I multiply by 60, don't I? That's going to do it for me. 60 times 1.3, 78 minutes. We are done. Good effort. Done in less than a lesson. You can definitely get through these. You will be faster because you don't need to explain them and record yourself trying to explain them. All right, keep up the great work, Year 10s. Keep working hard. You're going to do well in this exam and it's going to set you up for this year and beyond. Cheers. Catch you in the next one. Bye.